Welcome, everyone. Thank you for joining our webinar on the Industrial Internet of Things, IIoT. Today, we'll be diving into the world of IIoT communication servers, exploring not only how they work, but also the broader technology driving industrial IoT forward. My name is Erica O'Hara, and I'll be your presenter for today's session. I'm excited to walk you through this innovative space and answer your questions along the way. Let's get started. I'll present an overview of our offerings within the Industrial Internet of Things. We will begin with an outline of IIoT technology and ICP DAS USA's established role in this sector. Following this, I will detail our IIoT data acquisition solutions, focusing on the capabilities of our modules and controllers for capturing essential industrial data. Next, we will examine IIoT communication servers with a specific look at our UA series and their function in bridging disparate industrial and IoT protocols. Subsequently, I will address IIoT edge controllers, highlighting the intelligent devices we provide for local processing and real-time control within industrial environments. And I will also introduce IoT Star, our software platform for control and monitoring. Finally, a Q&A session will be held to address any technical or application-specific inquiries you may have regarding our IIoT product line. ICP DAS was founded in 1993 in Honshu, Taiwan, specializing in industrial automation and data acquisition solutions. In 2001, ICP DAS USA was established to expand our global presence and better serve the North American market. We are committed to providing fast service, free technical support, quick shipping, and reliable products backed by solid warranty. Our products are Royal House compliant and ISO 9001-15 certified, ensuring the highest quality standards for industrial applications. The Industrial Internet of Things, IIoT, applies IoT technologies within industrial sectors, connecting machinery, sensors, control systems, and enterprise systems. This connectivity enables the collection and analysis of vast amounts of operational data to gain insights, improve efficiency, and drive better decision-making. Key technologies include industrial sensors, robust networking, cloud and edge computing, and big data analytics. The primary goals of IoT are to optimize industrial processes, enhance productivity, improve safety, reduce costs, and enable new business models. By providing real-time visibility and data-driven intelligence, IIoT empowers industries to move beyond traditional automation towards smarter, more connected, and ultimately more effective operations, driving significant digital transformation across various sectors. The Industrial Internet of Things, IoT basically uses smart machines and devices that can talk to each other over a network. This lets them send data to computers and programs that look for patterns and meaning. People then use apps to see and use this information. It's all kept safe by security measures. A common way these devices talk is using something called MQTT, which needs a middleman called a broker, similar like a post office for data. This picture shows how factory equipment, OT, gets connected to regular computers and their internet, IT, using ICP DAS USA's technology. So on the factory side, machines and sensors talk using different industrial languages. ICP DAS USA devices act like translators, taking these languages and making them understandable for standard computer systems and cloud services like Amazon and Microsoft. Secure connections are used to keep the data safe as it moves between the factory and the internet. Once the data is online, it can be sent to cloud platforms for storage and analysis. Importantly, the system can also send alerts and information to smartphones, letting people monitor what's happening in the factory from anywhere. ICP DAS USA helps bridge the gap between the industrial world and the digital world, making it easier to keep track of and manage factory operations remotely. Data acquisition forms the very foundation of the Internet of Things. It's the initial and indispensable action of meticulously gathering unprocessed information directly from the network of interconnected sensors and devices that define the IoT ecosystem. This raw data acts as the sensory input for the entire system, making it absolutely essential for a multitude of crucial functions. Without this continuous stream of real-world measurements, IoT devices would be rendered inert, incapable of providing any meaningful insights into the environments or systems they are designed to monitor. Consequently, the ability to effectively acquire data is the pivotal first step in unlocking the immense potential of the Internet of Things, enabling intelligent actions, driving automation, facilitating in-depth analysis, enhancing operation efficiency, and ultimately contributing to safer and more optimized environments. So here you see the white series. These act as smart brains at the edge of an IIoT system, collecting data from local sensors, making real-time decisions based on rules, and sending key information to the cloud for central monitoring and analysis. The PMC and PMD theories, while focused on control in IIoT, they provide precise control over industrial machinery and can share operational data like speed, position, and status with other IoT systems for performing monitoring and optimization. You see here the ET series. These are data gathering workhorses, in IIoT, distributed throughout a facility to collect various sensors readings like temperature, pressure, etc., and transmit them over the network to cloud platforms for analysis and visualization. You see here the DL1000 series. These are crucial for logging historical data from industrial processes, providing valuable insights for trend analysis, predictive maintenance, and compliance in IIoT applications. The CL2000 specifically used in IIoT to monitor current signals from industrial devices like motors or actuators, providing data for energy management, fault detection, and overall system health monitoring. You see here the TM series. These offer simple and cost-effective remote I/O for basic sensors data collection or control in distributed IIoT deployments, especially where space is limited. The ISN series, these provide advanced networking capabilities within an IIoT infrastructure, ensuring reliable and intelligent data flow between various devices and systems. The ZT2000 series used for wireless sensors data collection in IIoT environments where running wire is difficult or costly, connecting remote assets to the central system via a gateway. And the WF2000 series, these offer convenient wireless connectivity for data acquisition and IIoT setups, allowing sensors and devices to communicate with the network over Wi-Fi. In the Internet of Things, a broker is like a central post office for data. Devices publish their information to specific mailboxes. at the broker, then cloud services and apps that are interested in that kind of information have signed up to those mailboxes. The broker's job is to take the mail and deliver it only to those who signed up. This way, devices and cloud services can talk to each other without needing to know exactly who the other one is, making the whole system bigger and more flexible. This image shows how ICP DAS USA's UA series helps connect your industrial equipment to the internet cloud for things like analysis. On the right side here, you see different kinds of industrial equipment that talk using different languages like Ethernet, which includes EIP and Modbus TCP, as you can see here, and RS-485, which uses Modbus RTU. These devices here send their data using a simple internet language, MQTT. The UA series products, which are these here, take the industrial data and send it over to the regular internet, or even using a 3G or 4G connection in some cases to the big public cloud platforms here. There's a brick wall shown, which means there's a secure connection or a firewall protecting the data as it goes to the cloud. The text at the top also mentions that the UA series lets you change the way the MQTT messages look using JSON before sending them to specific online services. These devices act like a translator and a secure messenger, taking information from your factory or industrial site and sending it to powerful computers on the internet for analysis and others, for mostly analysis, yeah. An IIoT communication server is a central hub that manages and helps different industrial devices, sensors, and control systems share data with each other and with bigger IoT systems, including the internet cloud. The UA2841M is the most advanced communication server in the UA series. It includes extra features like a SSMP v3 agent. This agent provides detailed network monitoring. The UA2241 series, such as the UA2241M, are standard communication servers. They're reliable and they translate between industrial and computer communication methods. These servers efficiently move data to local system or the cloud. The UA5231 series include compact communication servers like the UA5231 and the UA5231M. These models are particularly good at using the MQTT internet language, and MQTT is often used for efficient IoT data transmission. Some models in this series can also directly acquire data. Okay, so this picture shows how industrial data can go to different places. Look. On the left, data can be saved in databases like MS SQL or MySQL. It can also go to factory management system like MES ERP using Internet SNMP, OPC UA, or MQTT. From there, data can travel to the cloud, like Amazon or Azure, using Ethernet and MQTT. The cloud can then connect to apps on your phone using HTTP, allowing for things like if this, then that automation. The UA series device acts as a bridge to send data securely to the cloud. Bottom of the picture here explains some of the terms OPC UA, is a standard for industrial communication. MQTT is a way of IoT devices send data. Data logger saves data locally or remotely. IFTTT is a cloud-based automation. Cloud is how devices connect to the internet, and SNMP agent helps monitor device data in real time. So this picture here shows how industrial data can go to different places. On the left, data can be saved in databases like on the left, you have like an industrial sensor here, the DL301 IP65 that measure either CO, CO2, temperature, or humidity in a factory or building. It senses information using Modbus TCP. The sensor is connected to a communication server, the UA2241M. This server acts like a translator and a data manager. It takes the Modbus TCP information and can also communicate using other languages like OPC UA and RESTF RESTful, which computers and software often understand. The communication server then sends the process information using Ethernet and OPC UA to a digital sign called an Industrial IoT intelligent LED display. Like for here, it's like the IKAN-224. The digital sign shows information. In this example, it's displaying the data from room 2A computer engineering, including the day, which is August 16, and the temperature. So the picture shows a simple system where a sensor's readings are collected, processed by a communication server, and then displayed in an easy to read format on an industrial digital sign. An IIoT edge controller is a smart computer that sits right next to factory machines. It quickly processes data, figures things out, and controls the equipment in real time. This makes things faster and means it doesn't always need a constant internet connection to the cloud. It can talk to different kinds of industrial machines, clean up and combine data, keep things secure, and still connect to the cloud for overall management and deeper analysis. It makes industrial work faster, better, and safer, even if the internet isn't always perfect. This table compares two types of ICP DAS USA products for industrial use, WISE and UA series. WISE products are easy to use smart controllers. You can set them up using a website without needing to write code. They can follow simple if this, then that rules to control things locally and can monitor equipment. They can connect to many different types of sensors and send data to the internet cloud. They're good for on-site control and collecting data. UA series products are powerful communication hubs. They can translate the languages used by different industrial machines so they can talk to standard computer systems. They can also connect to the internet cloud securely, and some can even do simple local processing or follow basic rules. They're more focused on connecting different systems and getting data safely to the cloud. So IoT Star is our IoT cloud management software designed for straightforward remote management of our WISE, PMC, and PMD controllers. It needs no coding to set up, collects live and past data, mostly to MS SQL, and lets you make your own info screens. You can also update devices remotely and even use chat apps like Line and Telegram to interact with them. It works on private or public clouds and connects easily with other industrial system and data tools. This software simplifies the management and visualization of industrial IoT devices and data. So this image describes IoT Star. or software for remotely monitoring and managing the PMC WISE controllers in industrial settings. It's a web-based tool that's easy to use and doesn't require coding to set up system settings and monitor controllers. Key features include remote device maintenance, a user-friendly web interface, two-way interaction through a notification app, support for past and present data, and flexible installation on Windows or major cloud platforms like Microsoft, IBM, or Amazon. The image also visually shows various ICP DAS USA's controllers connected to the cloud, here, illustrating the software's remote management capabilities. This illustration, the IoT Star bot service system. At the center is the IoT Star cloud platform, which connects to various ICP DAS USA controllers and sensors like the WISE, PMC, PMD series here, via different communication methods like RS-45, which is Modbus RTU, and Modbus TCP. The key feature highlighted is the bot service. This allows users to interact with their connected industrial devices through messaging applications on their smartphones, shown with icons for Line, Telegram, etc. Users can send commands and receive real-time notification or data updates through this bot service. IoT Star also connects to a database to store collected data, which can then be accessed and visualized through web browsers on through a web browser on a computer or mobile device. This system lets you remotely talk to and get information from your industrial equipment using your phone through the IoT Star cloud. Indusoft Web Studio is a software for controlling and monitoring industrial things in the IIoT. It's a complete set of tools to create modern control screens and systems that connect to industrial equipment and use internet technologies. This software easily talks to different industrial devices and languages using IIoT setups. You can access and control your industrial processes remotely using web browsers and mobile devices, which is key for managing distributed IIoT systems. Indusoft can connect to databases that store the large amounts of data generated by IIoT devices for analysis and tracking. It also has pre-made graphics and dashboards to visualize IIoT data and control processes in a user-friendly way. This helps users understand what's happening in their connected industrial operations and make better decisions. This shows how ICP DAS USA sensors can display environmental info on a campus, digital signs. Sensors like BL-300 sends data using Modbus TCP to a UA2241M servers. These servers use OPC UA to show the info on the ICANN LED display, like room temperature. Here. The system encrypts the data for security and can save it in the databases, making information sharing on campus easy and secure. This image depicts a pig farm managed by an IIoT system, where an I/O module controls lighting, HVAC, and automatic feeders in nursery and growing phases, while industrial gas sensors monitor emission levels, with data from both being collected by a communications server and sent to a control center for monitoring and adjustments. Here is another example, a remote monitoring system for a renewable energy site, likely a solar and wind farm. Field equipment such as sensors and controllers, communication via Ethernet and Modbus TCP to a UA-2241M communication server. This server then transmits data over a wireless 4G GSM router using the MQTT protocol to a remote control center, enabling monitoring and management of the energy generation site from a distance. The bottom of the image shows solar panels and wind turbines. representing the monitor renewable energy sources. This concludes our IIoT presentation. Our contact information is shown here below. Hope you all have a productive day.